All right, welcome back. Welcome back. We're going to get this started. It is difficult to stop, meaningful and empowering conversation. So I apologize for being the interrupter. Sorry, not sorry. I do what I do. I want to take a moment to introduce our moderator on advanced manufacturing for Littoral Sustainment, Chief Warrant Officer Matt Pine. He is the United States Marine Corps' lead innovation officer for advanced manufacturing. With nearly 2 decades of Marine Corps service, Matt has led additive manufacturing integration efforts in Okinawa, Camp Pendleton, and now drives operational employment of cutting-edge tech from Camp Lejeune. He's managed everything from electro-optical repair and machining sections to innovation training for cross-functional teams. And whether solving battlefield sustainment challenges or remaining logistic workflows, Matt Pine has been shaping the future of Marine Corps readiness, one layer at a time. So give it up for him and his panel.
I appreciate that glowing intro. So welcome to the Advanced Manufacturing for Littoral Sustainment panel. I know this is the one you guys have been looking forward to the most. We're gonna try and keep it top level up here and then open it up for questions. That way everybody doesn't glass over when we start talking super technical details that you guys just don't need to worry about. So I appreciate AMCL giving us the opportunity to come speak about this. This is a very critical capability that really opens up a network of support, vice the supply chain that we all like to go with. And I appreciate the panelists coming in today to discuss your guys' work. I want to really highlight the projects you guys have been on and ensure that everyone out here understands what capabilities are being developed for us to reach out and touch. So first, we have Vince Bridgeman, Vice President of Red Horse here to my right, currently working CBM Plus and data logging across the DoD, doing a lot of work on that front. We have Dr. Paul Hartman, the Executive Vice President of RGBSI Federal and the DMX lead. Great tie-in on that last fireside, by the way. I appreciate that. And then at the far end, we have Abhay Kumar, formerly the Office of Undersecretary for Defense for Research and Engineering, currently with ANSWER, leading the JAMWIG and ManTech efforts, which have some really cool tie-ins as well. So I appreciate you guys coming in again. Thanks. All right, so first question, Vince, for you. A lot of discussion yesterday, a lot of discussion throughout the rest of the panels about data and logistics. Data is a driving force, we understand that. It also gives us the ability to forecast requirements. That being said, with your recent efforts in CBM Plus, can you discuss the impacts you've seen and what strategic advantage we gain from being able to do predictive maintenance and supply well forward?
Sure, yeah. A little bit about Red Horse in the context of CBM Plus and the data capture problem. So we've been involved in CBM Plus since the early days of the Joint Artificial Intelligence Center. We ran some of the early data exploration, looking at data sources for helicopters in particular. And what we found was the data was insufficient. So we ran some very early hackathons about improving the quality of data capture. And then I think I realized, and my teams have started to realize, it's really not about perfecting data capture. It's about doing the most with the data we've got. So we've taken that view, and we've been doing a lot of work with the Air Force on both reliability and sensor modeling for air platforms in Blade and Marine Corps ground vehicles. We built the Marine Corps ground vehicles MVP that's currently still in production for Tom Hale for some of the ground vehicles. I think the highest level view here is that driving logistics in a literal environment or anywhere in the world is entirely possible. And getting the data together, making sense of the data, it just requires some hard yards, some hard work. At the end of the day, what really matters is that we get the right data to the right decision makers at the right time. The hurdles to data capture can be overcome with creative data engineering, mashing up multiple data sources, and being smart about how we choose the use cases. But at the end of the day, it's a solvable problem. I'm eminently confident it's a solvable problem. I'll give you one example of some successes we've had. With the Air Force and the F-22 program, we're looking purely at reliability. The F-22 has some really great serialized data. The question the Air Force posed to us is our reliability improvement program making a difference, and can we get to where we know the reliability of a given part, generation of part, well enough to predict those needs in a deployed environment? And the answer is you absolutely can. We've proved that we can show over successive part numbers from part number A through part number G, one, that the reliability improvement program is improving, and we've documented that in a statistically valid way. And two, that we have enough understanding of that particular part number that we can make informed decisions about expeditionary loadouts and informed decisions about when that aircraft tail number is deployed, when we might need a new version of that part. And now what we're working on is scaling out that approach and that methodology across all of the part numbers, in this case for the F-22. So.
Awesome, I appreciate that.
You might need to R-square that mic.
Can everybody hear him? We're good?
We'd have that mic right there. I know we're not supposed to touch them, but thank you. There you go.
Logistics, give us a break.
Yeah.
Can we test it real quick?
If I speak really loud, can everybody hear me anyway?
This is better.
All right, great.
All right, we're good. Moving on, because your mic's not working. Just kidding, it's good now. Dr. Hartman, can you discuss so we had a brief overview of what the DMX is. Can you discuss some of the efforts that are currently happening across the Joint Force that the Marine Corps needs to know is there for us to be able to tie in? Because if we look at littoral support, it's a joint effort. We've discussed that over and over again here. We're going to continue to discuss it. But what do we need to understand to be able to tie in to resource that capability?
Yeah, good. First, let me say, Kurt, congratulations on your retirement. And I think we'd all be remiss if we didn't recognize Debbie Lilu back there from NCMS and all the great work that NCMS is doing to support all these different objectives and initiatives across the department. So, Debbie, thank you. Our booth, by the way, is back there next to NCMS. There's a track video that's running back there. It talks about the development of the DMX platform, the digital sustainment platform, and all that comes with that. I appreciate Secretary Kelleher setting the stage for that conversation. So thank you, Matt, for the question. The digital sustainment platform was designed, developed, demonstrated, and then delivered on behalf of the Department of Defense through the SBIR program. So it's a great success story about how the SBIR program is supposed to work, particularly in partnership with NCMS and all that we're able to do. The end state of the platform was just demonstrated this past week, both with Towson Warrior, where we provided, as Secretary Kelleher talked about, advanced manufacturing capabilities that were picked up by Australia, delivered to Japan for the production of a part to support Japan's defense industry. The second piece of that is just finished up yesterday, and it is the Trident Warrior program, the global naval exercise for the Navy, where we did provide, through the DoD Secure Unclassified Network, full access to engineering, manufacturing, product quality, supply chain risk management capabilities to the Navy to support advanced and additive manufacturing at the edge. So the entire project is really about pushing advanced manufacturing capabilities, whether that's additive or advanced manufacturing, like the use of CNC machines, so robotic process automation, in-process inspection. But how do we push that forward into a disconnected operating environment? So we started with the design, and I'll break there, but we started with the design of the digital sustainment platform so that we started in the mud hole. We didn't start back in the factory and start pushing capability forward. We started at a completely disconnected, ruggedized laptop, Starlink satellite communication system with a printer on board the back of a JLTV trailer. So we started in the field with the idea that what we need to do to support our warfighters is get you into the fight, but keep you in the fight by helping you recover from the fight and put those assets back into the fight again. And then we backed it up from there to fully integrate it into the DoD's Secure Unclassified Network. But just know that it's completely focused on how do we get the fighting capability of our nation forward and keep it forward for as long as we can absolutely sustain those operations. So thank you for the question.
I appreciate that. So I've had the pleasure, if you will, of running the last few joint exercises. Missed it this year, but that was a critical gap that we have identified continuously, is that ability to reach out and see what the network has, assigned to the nearest location and really manage the production the same way we look at managing supply. So I appreciate the work you guys are doing.
Sir.
For Abai, can you discuss some of the Mantech work that you guys do in support of AM, and then really what the Jamwig is doing to integrate similar to DMX, but on a much wider scale, not just on production?
Okay, so first, I think, can you hear me? Okay, so first, I should talk about my organization, which is Answer. So Answer is a non-profit organization dedicated to public service. Answer supports the government and specifically the DoD. Answer has celebrated its 65th anniversary in 2023, dedicated to the service to the government. Now, coming to your question about Mantech. So the Mantech organization has 3 line items, basically. So there are 3 P codes. The first P code is Mantech S&T, which is science and technology, and they operate mostly in MRL, TRL 1 to 3. Then we have the Manufacturing Innovation Institutes, which operate in MRL 4 to 7. And then after that, we have an education and workforce component, which actually encourages upskilling the workforce in advanced technologies, including AM. Now, in the MIIs, we have 2 MIIs or Manufacturing Innovation Institutes, which are specific to DoD needs on AM. So one of them is America Makes, and which basically is dedicated only to advanced manufacturing and additive manufacturing. And they have been influencing the additive manufacturing standards for the last 10 years. The other one is LIFT, and LIFT is actually more of a materials thing. So you can customize, you tell them the properties and you can customize the material. And from that material, they will be able to make the powder for the additive manufacturing and also rods if you're doing some sort of a different type of additive manufacturing. Now coming to Jamwig. So Jamwig is an initiative by DoD, and the strategic goals of Jamwig, let me just go back. Jamwig is composed from SMEs from all the services. So it's a government-only body, and the strategic goals are to integrate AM in DoD and Defense Industrial Base, align AM activities across DoD with external parties. So basically now you're including the Defense Industrial Base in this. And then advance and promote agile use of AM. I'll give you some example of that. Expand AM proficiency, learn practices and share knowledge. And finally, secure the AM workflow, because if you don't have security, then you got nothing. So coming to the other point, what we are doing with other countries. So we have been, as everybody knows, you can do advanced manufacturing on a machine with a particular process parameters, and things should come out same, right? Unless there is some problem with the cybersecurity, right? But now if you take this process to another machine, then you have a whole set of problems. And that is what we are trying to do with the UK right now. So what we are trying to do is we have certain parts which have been organized. They are going to be doing those parts, and we are going to be something similar on different machines. And then we are going to validate them, test them, validate them, and figure out how we can do this collaboratively over machine. Why it is important is when we need search capacity, then we can depend on our allies to actually do the search capacity. So another part of the MANTech program is JDMTP, Joint Defense Manufacturing Technology Panel, where all the services are, and DLA, all the services are involved, and they bring back projects for what they're doing. And this is to ensure that there is no duplication between the services. So we were talking about just now, I think Mr. Kelleher was talking about problems between AM processes and advanced manufacturing, between R&E and ANS, and in ANS, the other component of ANS. So here, this is trying to get all the projects together at the JDMTP level. So we have representation, they bring in the projects, and we make sure that there is no duplication. And if there is some duplication, then those people can collaborate and make it one project. So that is, I think, coming back to now the institutes again. Like Mr. Kelleher was saying, that if your company is making a widget for one commercial use, they can also make something for defense use. And that is the purpose behind these institutes. So the institutes were formed as a public-private partnership, and public-private partnership where it is led by industry but actually controlled by DoD. And what we do is get DoD-centered projects in the 9 DoD institutes which we have, DoD-centered projects, and we are able to advance technologies for DoD use. And so what happens here is many projects which companies and DoD would not do by themselves, they get 1:1 cost share, and they are able to do with the help of industry, and then both the industry and the DoD is benefits. So here it is like the high tide raises all ships.
Absolutely. So to highlight some of the work, you talked about American Makes. So recently we had American Makes come down, just so you guys understand the impact of what they're capable of bringing to us. So American Makes came down, and we just recorded a training instructional video for them on how to produce your own quadcopter drones based on super basic electronics, alignment, programming, and flight. So they're looking at all the technologies that are out there, and they're trying to figure out a way to get that training out for us. So the educational workforce development, that's going to be significant for your Marines. They're also developing a training platform where you can go on and build out a profile for Marines and say, hey, I want you to understand basic AM functions and networks. Do these trainings, so similar to how we use MarineNet, and they'll be able to pull down those trainings and work through them so they can get certified through American Makes, which is actually going to be a transition for them if they decide to get out to really help feed the industrial base as well. So really the goal is to utilize the DoD to help feed the industrial base long term. In the meantime, we get that capability for now, which is a win. I appreciate that information. That was very thorough. So as we look to figure out, one of the other big problems we have with AM in the littorals is really AM everywhere, and that is figuring out what we need to make. So knowing that, understanding that you work with CBN Plus, Vince, what is that tool going to give us for predictability? And then what level of visibility should we have? What level of visibility do we have? And someday, can I expect a joint force commander to sit at a computer and see things like battery levels and fuel levels?
Yeah, this is a great question. And I'll start with the last question first. And the answer is 100%. Obviously, we can do that. We could do that today. We could do that 20 years ago. A quick vignette. I did some time with a venture capital group in the government called InQtel. we were looking at some of these kind of hard problems back in 2005. And we were visiting all kinds of commercial industries to see how they had solved these problems and where they were at in the show. In 2005, Snap-on Tools could monitor the state of every Snap-on Tools truck that was out selling. They sell basically out of their truck. Could monitor the state of every vehicle and the supply in every vehicle, the number of tools and which parts. They could also predict in that particular vehicle on that route on that day how many of which tool they would need based on their past experience of selling to buyers. They drive around and sell to mechanics all around a particular territory. They could do that in 2005 in real time. So what we face is not a technology problem, right? It's a people and process problem, right? It's authorizing officials saying you can't do that with my network. It's the problem of data governance. There's a lot of people problems. So I'm confident we can do it. If we go back to the idea of fundamentally, CBM Plus is maintenance performed based on the evidence of need. If you understand that idea and then you say, where is the maintenance being performed, we'll understand that we have to have the evidence of need has to happen on the island. It has to happen in the expeditionary environment. If you understand that, that means that we have compute and data and models running at the edge, and the first inclination that we will need a part is going to happen in that deployed environment. That is where the base understanding, that is where the combination of statistical models, sensor models, supply history, readiness, mission profile, environmental conditions, and the human observations of the operator are going to come together and say, I need a part. That's going to help to drive this question of, when do I need that part? Where is it needed? How urgently is it needed? So I absolutely think there's a future, a near future, especially if we all work together and drive hard through these human problems. There's a place where CBM Plus is going to give you a reliable prediction of when you're going to need to, crank out some advanced manufacturing parts and get them off to the people who need them.
Awesome. I appreciate that. So I got a couple primer questions and then we'll open it up. So this is open for the table. Understanding that we need to have contested support networks, not just a supply chain or an Iron Mountain. What is the data visibility realistically today? What is the tech data pool that we have today? And then what can we do now to get ourselves ready for a fight tomorrow that we're not doing today? What should we be doing better as Marines?
Good. I'll take first swing at it. First, I'd like to recognize the folks at the 3rd MEF, the folks down in Albany, Georgia as well, with Kirk's team and all the work that we've been able to do with the services. The folks over in SOCUR have been instrumental in designing these questions about data integrity, the validity of the data at the edge, have all been baked into the platform by design. And it's from working with folks like you, Matt, that as you know, the critical importance of that. I can tell you right now, if it comes to maintaining a legacy weapon system of any size, complexity, we have the most terrible, I don't know of a better word. It's just, if you go into GEDMix and try to pull a technical data package on any weapon system, at the system level, at the subsystem level, at the assembly level, or at the commodity or component level, it is ridiculous. It's an old scanned in drawing, so it's digital because it's now PDF, right? But it's got a stamp on it that says best drawing available from 1943. And oh, by the way, the mechanics coffee ring is on all of the manufacturing specifications and standards. It's been scanned in as well. So now I have a digital representation of the mechanics coffee cup on there. So one of the things that I think that we really have to get after, and I know this was Daryl Roberts, the CIO from DLA, was on here yesterday. One of the things that we have to get after is the 2D to 3D conversion of the technical data packages to turn them into usable technical data quality packages that OEMs and small to medium manufacturers and even across the organic industrial base can use those technical data packages to go out and recreate or reproduce parts on demand, as may be indicated through a condition-based maintenance plus approach. But I'm not advocating at all that we should go out and we should spend billions of dollars cleaning up legacy technical data packages that have a one-off requirement. I think that what we're talking about is the right place at the right time to take advantage of the technical data, the engineering tools applications that are available to you to recreate that technical data in a usable form. I could have conversations all day, but I'll break here about the right to repair versus right to use the OEM's IP. We could talk in depth and detail about that, but we do have to figure out as a nation about what we're going to do in terms of the ability to repair our assets in the field at the point of use, at the point of need, and then work that back through first and second island chain activities. But I think the data integrity issue we can address and we can solve. I think we just need to be smart about where we make investments in that data in terms of improving the quality of the data so that we get good use for every dollar that we spend in terms of a data cleansing exercise or a data validation exercise.
Appreciate that. Any other input? No? Awesome. Okay.
I'll jump in.
Okay.
Yep. So first of all, absolutely agree. Any improvement to distributed decision-making or point decision-making hinges on good information, well-developed knowledge and understanding. Ultimately, that rests on data. So I just want to double tap. Anything we can do to improve data quality, whether it's on the technical package or bringing in environmental data, at the end of the day, getting the right data to a decision maker is the essence of making these sort of distributed decisions that result in, sort of logistical advantage. I'll also say that understanding, there's probably only a handful of people care about this, but understanding the technologies that are available and making sure we're using the right technologies for the problem. In particular, and this is deep esoterica, in particular, logistics is a network problem, right? There are technologies that are available that make network problems a lot easier. Graph tech, if you're involved in technology, graph technologies, if you're not already familiar with them, you should understand that graph databases, graph technology, graph analytics absolutely changes the way you are able to approach these kinds of network distribution problems. You combine graph technology with agentic workflows, and pretty soon you can build some really powerful decision systems that are capable of tackling a complex, distributed, literal logistics problem. And I'm not making this up. I'm not pitching technology. This is what industry uses, right? This is what United Airlines uses. This is what Caterpillar uses. Like, these technologies are available, and knowing how to use them is not hard to discover. What happens is we get behind a wall in DoD and everybody's using, kind of the last generation of technologies we've mastered. I definitely invite people to look at graphs as a differentiator when it comes to building logistics decision systems.
All right. Thank you. So from there, we'll go ahead and open it up. Does anybody have any questions on the crowd? Absolutely. One over here.
Ask something difficult.
We've identified the problem. Now what? Is that what you're going to say?
Almost. The problem here is qualification and certification. I'm not asking that question. Examples. This is really just, listening to the profile here. I've spent the last 2 years leading the effort for NASA to get engaged with advanced manufacturing. I don't have a good report. I'm just looking for examples of better, cheaper, more ready parts. Like, who's winning? And that can be a business, public-private partnership, or government-led. But who's making better, faster, more qualified, more ready parts?
I'll take a jab at it, and I want to do it from a commercial perspective. We know right now, as an example, Ford Motor Company, I'll talk openly about them. We know right now that we can absolutely print with better material properties an entire brake assembly for any car that Ford makes. But the Ford lawyers will tell you that there's only two primary braking systems in a car. It's the airbags or the brake assemblies. And so they're not in a position mentally to leap forward to the idea that we could absolutely print. This goes back to the people problem that Dan talked about, but also what Secretary Keller talked about. It's a mindset. So we know that we can absolutely replicate any material structures, whether that's in polymers, that could be in alloys or pure metals. We can absolutely do it at scale, but it's an adaptive process in terms of adapting the mindsets that go with that. One other point, and I'll break. I hosted the first DoD-wide additive manufacturing symposium, and I had Admiral Stephanopoulos from the Navy, I had a 1-star from the Marine Corps, and I had a young lady from the Air Force. And let me just give you the end of the story. Admiral Stephanopoulos said that we will not declare initial operational capability for the United States Navy until I can print underway a hatch on a submarine. The Marine Corps 1-star said we're declaring full operational capability because we can print a mess kit in the field today. And the Air Force is all over the map because of flight safety critical items and critical safety items. So there's this whole continuum about who's doing it well and who's doing it right. But I can tell you each of the services have pockets of goodness of where they're doing additive and advanced manufacturing applications today. But we just can't get out of the starting blocks with moving it at scale into forward operating locations for repair.
So let me,
Can you highlight 2 of them?
sorry.
If there's places where it's really, really working, can you highlight a couple of them?
I'll give you an example. I won't try to remember the full name of the office. And if you're really interested, I can get it to you afterwards. But there's an Air Force office working at a Hill Air Force Base. And anybody who's worked on airplanes know the parts are quite expensive. And in particular, I think it was the F-35, when you have to replace a bearing pack in the landing gear wheel, you pull the wheel off, and the pack needs to be replaced, but the wheel itself, when you pull the bearing pack out, the wheel itself also has to be replaced. It's a press fit item. And so they do basically an additive manufacturing repair to that now. So instead of throwing away a $75,000, $100,000 wheel, you just recondition the wheel very quickly, and then press a new bearing back into it, and you're off to the races. So now you're saving, now instead of $75,000 for every time you got to change that bearing on top of the cost of the bearing and the maintenance, now it's a $100 process, right? So that's one example. And if you want to get the name of that office, I'll get it to you afterwards.
There is something to be a little cautious here. And the thing is, test and validation is very important. And what you have is 3 ways you can do that. You can do process equivalency. You can do statistical analysis of systems, and evidence-based qualification and model-based qualification. So one of these has to be done before you can do any critical part. So that is number one. The other question was regarding what has been done. So in our office in Mantech, we did what is called point of need challenge. And this point of need challenge was basically is specifically relevant over here because this was to do additive manufacturing anywhere at any climate. So this was basically done at about minus 40 degrees. And it is basically the Army's Engineer Research and Development Center, Cold Region Research Engineering Lab, CRREL, in Hanover, New Hampshire. So it was dead of winter, 40 degrees, minus 40 degrees, and I think Matt was there.
Yes,
so he was froze with everybody else.
Yes.
So over there we had 3 people in additive manufacturing. One of them was Nscript, which actually brought a factory in a truck, in a semi truck, where they could do 3D printing at the point of need at minus 40 degrees. The other one was Speed 3D, which also printed technology in hot and cold climate both. And they said that the properties were the same as what they had in the lab. And the third one for this 3D printing was Crater from San Diego, California. They were trying to de-risk 3D printing capabilities in that cold weather. So we do have, this is a limited scale, but we do have examples of what 3D printing could be done in what type of weather.
So speaking of that exercise, the other one that he didn't mention, because we like to talk repair parts, we actually worked with a company out there that was generating red blood cells from platelets. Absolutely insane, but like a forward deployed blood bank where you just create blood was insane. So that honestly, that was the coolest one
That's
for me being
biofab.
there.
That's biofab, you're saying?
Yes. So the technology can go anywhere and touch anything. So it's not just repair parts. It can do a whole lot of stuff. I'll give you one more example because this conveniently is what I do for the Marine Corps. We have an egg beater antenna for a MUOS man-packed system. Right now they're $5,400 each-ish. Plastic mast in the middle holds the whole thing up. When that breaks, you have to order a new one. We generated a design for it that we could produce for less than $10. If we replace everyone in the Marine Corps right now, it'll save us $990-something thousand for one part of one part. So the applications are endless, but it takes folks like the ones in the room to go find that solution, because we can't solve every problem. So somebody needs to come tell us what problems to solve, unfortunately. Moving on. That answer your question? Great.
Hello. Sorry, I was handed a mic, so I'm just gonna go for it. Hearing some really encouraging things around the AM space, especially over the last few years, everything from repositories to declaring what a critical part is to all the kind of policy stuff that has to be in place for our warfighters to be successful. What I haven't heard a lot of talk about, particularly today, is the warfighter side of it. There's not a lack of AM machines out in the fleet right now. There is a lack of policy, which we've addressed a little bit. There is a large gap in what development and support we are giving for those warfighters to actually do the thing. And some of that is policy, but some of that also is how are we developing those warfighters to feel comfortable using the technology? And Matt, this might be a little more geared towards you, but what can industry do to help support that, to boost both the knowledge, but also just the confidence that this is a tool that they are allowed to use and can start running with?
I think I can take that. So there is a DoD standard, DoDI 5000.93 for use of additive manufacturing in DoD. It basically is a policy document. It also has roles and responsibilities and procedures and guidance. The other thing with this there is to align with these priorities in this document, DoD has got different groups which have been formed. So there's Joint Additive Manufacturing Model Exchange, which is how they come up with the acronyms, I cannot tell you, but JAMX, Joint Metal Additive Database Definition, JAMAD, Joint Additive Manufacturing Acceptability, JAMA, and AM Data Package Approach, Additive Manufacturing Portal for Education projects. So these are the things which have come out of the DoD to help users do this. And in addition to this, DoD already has 620 plus additive manufacturing machines which are deployed, and 2,000 plus trained people. Now this data is little dated, 2 years old actually. And 30 plus materials have been approved for use. So, and nearly 6,000 AM TPDs have been created and can be used. So whether it is industry or DoD, this should be useful to all of them.
One of the challenges that we face right now is how do I get a cognizant engineering authority or a service level engineering activity to sign off on an additively manufactured part, whether it's a door handle for a Jeep or it's a hot section engine component. Like I said, the material properties are there. I think we have a training issue where we need to train our engineering workforce on what the future of these advanced manufacturing. And I do note that the title of the panel is advanced manufacturing, not just additive. We can spend a lot of time talking about where additive is going, but advanced manufacturing is the same way with multi-axis CNC operations, the use of plasma spray. There's so many leading edge manufacturing operations that we can make forward deployed, but some of that comes back to service level policy. So we know in general that if the policy doesn't say that you can't do it, the Marines will do it. And if it doesn't say you can do it, the Navy will not do it. And then for the Marine Corps, or for the Air Force, again, it's somewhere in the middle, depending upon who the commanding officer is in and working with those service level activities for the engineering approvals that go with that. So we're a long way away, I think, from a policy perspective, even though we have the DoD instructions. I think the service level policies and certainly the command level policies that go with those. But I think it comes back to this training, this awareness issue that Secretary Keller was talking about, this idea that we're doing a lot of great things all over the services. They're just not integrated. And I don't know that another JAMX, a JATM, or what, React, Rearm, I mean, there's so many of these organizations that are out there, but there's not a single standard. And that's where I really appreciate, I don't know if you guys know David Anderson or not from the Log Command, and I know Kirk does, they've worked for him, but David Anderson is really taking out and leading the way on what it looks like for a service level application of both additive and advanced manufacturing, particularly on depot maintenance operations. And I like the way that Secretary Kelleher classified that. It's heavy maintenance operations going forward because we're not going to deploy our depots. I think we'll get into some of those workload related issues. But anyway, I do appreciate what the services are doing. I think that what Secretary Kelleher is doing in terms of trying to integrate all those wet cats, I think it's going to serve us all well going forward.
Yeah. And the one thing I'd add is that for a service that's implementing an AM program or system writ large, there's two things that they ought to borrow from what the rest of DoD sustainment is doing. One is obviously CBM Plus, right? You're deploying machines that need to be maintained and repaired themselves. And if they don't work, well, then you can't print the parts that you need. So you need to bake that, because this is a new initiative. You need to bake that data capture and those processes and the analytics into that. The second is the idea that these are complex machines going to be operated by Marines deployed someplace. Those machines should get the same benefit that all the other systems are getting from having these intelligent deployed maintenance aids, right? Guides, whether they're augmented reality, virtual reality, or just a really well-designed tablet application that allows you to quickly diagnose, is the machine working properly? Is it printing parts that I can trust? Does the data reflect that? Those things have to be baked in, and I think that begins to solve some of the people problem you were getting at the beginning.
So I'm not a panelist, but I'll say something. So from the guy on the ground again, I'm doing the training right now at Camp Lejeune. So the biggest thing that we have to get out and get out to the Marines and get out to the warfighters forward is exposure. Because once they understand a capability, they don't have to be able to apply it, but once they understand what the capability can do, they're going to figure out a way to use it. And then that's when they get dangerous. So really focusing on a basic level understanding of what the capability can do, which comes back to the engineers, comes back to everybody who's in the way right now. Once they understand that, they'll start to figure out how to weaponize it. We have so many people coming through the campus down there that it's growing quickly at TUMEF. It's getting very dangerous compared to where it's been in other places. Solely because they have that grasp and understanding of how to weaponize it.
I want to say that there was a Marine Colonel that we were working with this past week for Trident Warrior, and I think his statement was probably the one that most accurately frames this. I didn't know we could do that. And we're talking about using the digital manufacturing exchange, the digital sustainment platform, to be able to go in behind a secure and classified network, which provides access to our allies and military partners around the world through a role-based permissions and accesses activity. He didn't realize that right there at the point of need that we could download under configuration, under control, the additively approved models to print whatever that particular asset was that was in the TDP. So I think some of it is not just the education component in terms of training people on how to do this correctly, but the idea that there are capabilities that are out there that people just don't know exist. And I think, again, that goes back to what Secretary Keller is trying to do in terms of lead that flag from the Pentagon and then push that out to the combatant commands and others.
Yes, next question.
Probably a question to follow on Cheyenne's question, which I thought was very valuable. How are you addressing with the data and with the DMC the creation of manufacturing lines? When we made a lot of things before, our factory had 20 or 30 tools that we created a manufacturing line to produce something. And we orchestrated raw materials coming in, and then we use those tools to convert into a finished product. I hear a lot about advanced tools. How are you taking and creating lines that we can actually make things in the field? Are using the data to help Marines create those pathways or plans to actually make things using a multiple set of different tools or devices?
So one critical piece of your question concerns tooling and fixturing, above and beyond something that we might produce with additive or advanced manufacturing techniques. Some of the tooling and fixturing is covered by the same IP as is the tech data that's associated with the manufacturing of the part, that the OEM may own all of the tooling and all of the fixturing that makes that manufacturing operation even possible. In the digital manufacturing exchange, we do provide all manufacturing specifications and standards, all mill specs, all mill standards, the maintenance package that comes with that technical data package as well. But as you know, we're talking about a single seat in a forward deployed operation where there are thousands of seats in the AOR. So I think the most important thing that we'll do is figure out what we're going to do in terms of a machine-based standard right now. And you heard Secretary Keller talk about whitelisting of all the machines that are out there. There's just so much to this right now when it comes to how do we actually use this stuff in an operational environment so that the folks out on the pointed end of the spear are not worried about keeping the maintenance alive on their additive manufacturing machines, but they're worried about keeping themselves and their buddies alive as we push forward into the fight.
Any other questions from the group? One more. Okay.
Hi, my name is Bindia Vakil. I'm from Accio 3D. We are leveraging AI agents to help identify parts that are 3D printable, the end-of-life parts in particular. Obviously, you talked about graph databases and AI agents and workflows. So what are, in your mind, some of the challenges we should be aware of or prepared for when it comes to leveraging AI in the DoD to solve the AM end-of-life part problem at scale?
Yeah, I mean, I'll jump on that. I mean, I think it's a little bit beyond logistics, but happy to respond. I think at the highest level, one of the challenges we face, particularly if you're bringing in agentic and when people say agents, they mean different things, but let's start with large language models acting as agents, right? Getting those deployed, accredited for a particular system or network is often a challenge. There's a pretty good center of excellence happening right now at CDAO in the AI Rapid Capability Cell, the AIRCC, I think it is, where that's their whole focus, right? That was previously Task Force Lima, which was the CDAO task force on LLMs, and that's flipped over into their sort of center of excellence for large language models. So the knowledge base that's there can help any vendor communicate with an AO to get LLMs approved for a network or a particular use case approved for a given network. So that's, I think, an important resource. And happy to talk with you afterwards to give you points of contact there. I think beyond that, it's just understanding beyond the security accreditation questions, how do we constrain how the system performs, and then how do we develop a way to be trusting of any recommendations or outputs? How do we generate some transparency in the way the system is generating a recommendation or a course of action? And that's going to be extensively driven by the actual use case and the human decision-making requirements behind it. So I would just say, focus on the user, focus on the decision that the user has to make and the context that they have to make it in, and then design the system in a way that exposes enough rationale that the human can trust the recommendations and that we can validate those recommendations. Yeah.
So I just want to supplement that, and that is whatever you're making at the component level and at the system level, it is important to do the test and validation, because additive manufacturing parts, many times when they are stressed, they behave slightly differently from other parts. So it is important, test and validation at both the component level and system level is very important.
I think to your question, if I had, I don't see Kim here are you here somewhere? No, from yesterday's panel? 100,000. Right now we have 100,000 weapon system coded part numbers, NINs, in the DoD. That's just top level. But 100,000 part numbers right now that are in DMSMS or material obsolescence condition. So if you want to talk about the application of artificial intelligence and how to get after a problem that needs to be solved right now, I would say DMS and material obsolescence is the place to go. Your question was about how do we identify which parts would be suitable for the application of advanced or additive manufacturing. In this case, I assume you're talking about additive manufacturing. What parts are out there right now that would be great examples and use cases where you could create a part family type of a certification for any cognizant engineer or service level engineering activity. But there's probably part families of items that are out there: screws, nuts, washers, brackets. They're low complexity manufacturing operations. But if we went back to traditional manufacturing of reductive processes and creating it on a mill or a lathe or something like that, it's very, very intensive to do so. And so a manufacturer whose cost economics says, I need to make a 1,000 part run in order to generate any real revenue here, I'm not going to make 5. So anything that you could go through, any of those DMS material obsolescence coded part numbers, and identify which of those through traditional manufacturing operations, finishing, heat treat, specialized coatings, there's got to be half of them that you could quickly apply certified additive manufacturing operations against and solve that, and then produce on demand or as needed. And I think the general said yesterday, can I just produce a sack of those? And yeah, if you need a sack of them, you should be able to do that. But I think the application of artificial intelligence to penetrate into GEDMix, into those technical data packages, into those drawings, use optical character recognition as necessary, because that's really the best tool you're going to have. But I think you could get after that problem right away.
Awesome. So we got 6 minutes and 56 seconds left for anyone counting. On that note, I'd like to give you guys a chance to really, any parting shots, any parting wisdom for us to really help us shape our understanding and what we need to do leaving here to really weaponize this capability.
Go ahead, sir. Yeah.
Well, as far as I know, that the point of need manufacturing actually really exposed a lot of capabilities in the industry. And also, we also came to know about the adaptation of additive manufacturing in especially the Navy, for instance. So there was a couple of Navy ships which already are using additive manufacturing machines on board. So I think we have a good start. And if we keep on at it, we will be able to get the full potential of additive manufacturing.
I would challenge the services to really get after what are your intentions in terms of additive manufacturing. What do you really see your future looking like? There are those industrial base operations at the arsenals, the depots, the shipyards that lend themselves to the investment in the industrial base for large-scale additive manufacturing capabilities, whether that's polymers or alloys or pure metals. But that's not a deployable footprint, right? Because a lot of additive manufacturing is very unstable. You don't have to think too loudly about that to know that if I'm bouncing around on a JLTV and I'm trying to print something outside of the Crater program, and I'll put a plug in for the guys out there in California, because that's a fantastic capability that they can turn that thing upside down and somehow still hold print form. I haven't tested that yet, but I like where they're going. But I would think that it's incumbent upon each of the services not to just chase the buzz, but to really figure out where do you want to be able to apply at scale the future of additive and advanced manufacturing technologies. And then certainly look at those operations that you have cognizant engineering authority over that could push those forward into the fight, whether that's in Guam, Australia, Japan, South Korea, or Hawaii, or Indonesia, the Philippines, Thailand, Taiwan. I mean, we're trying to cover down on pushing additive manufacturing anywhere that we've got someone in a uniform that is pushing our U.S. national interest forward. So I think that I would part with that I don't know that there's one size that fits all. I don't know that it's a secretary level issue. I think the secretary of each service should probably figure out what that future looks like for their respective services and invest in that, and then begin using that so that we can associate training and education and outcomes that we're looking for. Good. Thank you again for your time today. I really appreciate being up here.
I'll take a slightly different cut. So we support the SOCOM Unmanned Systems Program, where we're doing the software and AI architecture for the entire enterprise program. And the program manager has exactly the right point of view, and I would encourage everyone here to think this way. He has 2 lines of effort in his program, right? Line of effort 1 is building this future vision in the best possible way that he can. Line of effort 2, arguably the most important line of effort of the 2, is what do I do if I have to fight tomorrow? And I would encourage everybody to think about what's the next most valuable thing I would do if I had to fight tomorrow. So don't deploy a predictive maintenance system that has to wait for 5 years to give you all the predictions for all the parts. Go find the part that drives the most pain in that particular weapon system and get that deployed. And then use that to drive contest logistics and use that to drive readiness or availability. And then iterate, right? You can't lose sight of the long-term vision, but we have to remember we're doing this so that the fight is a little bit less fair when we have to fight it. So what can we get into place now to improve whatever metric we're trying to improve?
Can I add one more thing? I was thinking about the whole purpose of Trident Warrior as an example is not necessarily an operational military exercise as much as it was classified this year around cybersecurity. So they classified it as a cyber contested environment, right? Not necessarily contested logistics, but a cyber contested environment. So again, I would push that back to the services and say we really need to figure out what we're going to do at the service level. As an example, with the digital sustainment platform and digital manufacturing exchange, we're running that in behind the DoD secure unclassified network for a reason. That's because each of the services have their own ATO policy. So we have a full ATO for the digital sustainment platform behind SUNNet. So what Secretary Keller was talking about is that you have an ATO at the DoD level. Why wouldn't the services also be able to use that ATO to authorize those tools, applications, and services to run behind their architecture? Those are some of the service level issues that are going to get in the way, I think, of being able to share models, to be able to share capabilities across the enterprise, is because we have those service level policies that get in the way of where we're trying to go. So just add that one in there if I could. Thank you.
Awesome. I appreciate you guys' time. Can we give them a round of applause, please? It was good discussion.